So this is a little bit of a review or a short tutorial on how the solvent plays a role in the rate of SN2 reactions. And before we do this, we have to talk about the two types of solvents that we can use for this SN2 reaction. Now, first of all, we're going to take a nucleophile and we're going to add it to a carbon with a leaving group to produce a substitution reaction where the negatively charged nucleophile is going to replace the leaving group, which will then become negatively charged. Now, if we're talking about what kind of solvent do we need for this reaction, in order to solvate these two anions, the solvent must be polar. So we cannot use a nonpolar solvent for this. And there's two types of nonpolar solvents. There are what are called, in most textbooks, protic and aprotic solvents. I'll capitalize the A. So there's protic and aprotic solvents. I will use another term for protic, and I will call them hydroxylic solvents, which is a little more descriptive of what they are. And then aprotic are non-hydroxylic solvents. So these are the two classifications that solvents can be. So let me give you some examples. For protic or hydroxylic solvents, water, alcohols. In other words, anything with an OH group attached to it. And those are going to be able to undergo some hydrogen bonding, or they're going to be able to solvate the negative charges very, very well, because we've got delta positive hydrogens in those protic or hydroxylic solvents. The aprotic solvents are things that don't have hydroxyl groups but are still polar. The one that we use a lot in lab is acetone. But there are others. There is sometimes diethyl ether is classified as a polar aprotic solvent. Another has a CH3 attached to a sulfur with a double bond. This is sort of a sulfur analog of acetone. This is called dimethyl sulfoxide, which is abbreviated DMSO. We also have things like CH3 with a C triple bond N. That is called acetonitrile or acetonitrile. And another one that the textbook uses a lot has an H attached to a C double bond O. There is a nitrogen with two methyl groups on it. This is called dimethyl formamide, which is abbreviated as DMF. So all of these are polar solvents, but they do not have hydroxylic or OH groups on them. And the difference then is the way that these two solvents solvate anions. Protic solvents are much better at solvating ions. And in this case, we're talking about anions like the nucleophile and the leaving group. Aprotic solvents will solvate them as well, but they're not as good at solvation. And let me state this another way. When I say they're better at solvating, that means that they interact with the anion more strongly. So I would say that they are stronger. I'll just say stronger. These are stronger at solvation, of solvating the nucleophiles and the leaving group anions, whereas these are a little bit weaker at solvating. A little bit weaker at solvating the Nu minus and the leaving group. They still will solvate, but they just don't solvate as well. So this is how we lay out the two different types of solvents that we're going to use. And the book uses protic and aprotic. If you've done, like I did, some PhD work in this area, what you find is that protic and aprotic are not necessarily the most descriptive terms. So I like to use hydroxylic, non-hydroxylic. It really doesn't matter. But these are the two classifications of the solvents that we need to use, and these are their key differences. That protic solvents solvate anions stronger than the aprotic solvents, which still solvate, but not nearly as strong. Okay. So I'll use these basic ideas in answering some of the questions that we have in the chapter 7.